Hello, welcome once again to my channel for the continuation of differentiation of trigonometrical functions. Now this time round, without wasting a lot of time, we are basically going to build up our knowledge of differentiation from the chain rule in the previous video. Now in this video, we are going to learn how to use what we call the product rule to differentiate trigonometrical functions. I'm going to begin with a general example again that says differentiate the following functions with respect to x. And the first function is sin x cos x, b sin squared x cos x, c cos squared x sin x, and these many others. Now, the word product comes from a common word that we know. It implies multiplication. So why are we going to use it? We are going to use it because we have at least two functions multiplied together. So I'm going to begin with part A by simply letting y to be, I'm going to let y to be sin x cos x. Now I am sure you already have the previous knowledge about product rule, but you might have used it to differentiate non-trigonometrical functions. Now today it will be basically either only trigonometrical functions, or we can also have a mixture of an algebraic expression with a trigonometrical function. For example, as you can see this, we have an algebraic expression here and a trigonometrical function. Let us do what is supposed to be done here. So since we are going to use product rule simply because it is the product of sine and cos, it means I can call this any of the variables, for example u, and call this v. Now if u is equals to sine x, it means the u dx, will be cos x. Because when you differentiate sine x, you get cos x. Then if v is equals to cos of x, it means the vx will be minus sine of x. Now from this point, we have to remember our formula for product rule, and that is dy dx is equals to v du dx plus u dv dx. Remember that is the formula that was derived earlier on when we were doing differentiation 1. So from this level, I'm going to basically do the substitution. I'm going to substitute for v. So it means I will have dy dx as v. I have v as cos of x. Substitute for du dx, which is cos of x again. Then plus u. When I get u, our u is given as sin x. Then I substitute for dv dx. dv dx is minus sin x. So because it is a minus, I will apply a minus there. Then I will have to put sin x there. So this comes to cos squared x minus sin squared x. And if you remember this very well, from our double angles, cos squared minus sin squared can as well be written as cos of 2x. So it means in conclusion, I can say dy dx is equals to cos of 2x. If someone remains at this level, of course you still get the marks, only that it will be so much good and better when you think of a double angle, and that becomes the best simplified result. So that is our part A. So you can imagine how simple it is. You can now move to part B. So part B says we differentiate sin squared x cos of x. Now the issue about this is basically going to be this, because now we have a square. But you need to still get back to the normal ideas that you have. If I let this to be u and let this to be v, it means u can be written as sine of x. I can have a square out. Then we are going to use a shortcut of chain rule to differentiate this function. And what is the shortcut? Drop the power. We are going to drop the power. So I'm going to say du dx is equals to, I'm dropping the power. We differentiate function within the bracket. If I differentiate sine x, I'll get cos x. Then you write back the same bracket with its content, but reduce the power by 1. So it means I'll have this as sine of x. Because if even I had the bracket with power 1, it remains as sine x. And if you look at this very well, you can either leave it at that level, or you can even simplify it. You say this is the same as sine 2x. Remember, that is again from double angles. That is again from double angles. We move on now to v. Our v, remember this is already the udx. Our v, according to be cos of x. Then we also get the v dx. So the v dx comes to a negative sine of x. Now, from this level, we can now apply our formula again. That is the product rule, which says dy dx. This is dy dx is equal to v du dx plus u dv dx. From this point, we do the substitution. So I have v, which is cos of x. I have the u dx. U dx is going to be either you write this, or we can write the most simplified form of it, sine of 2x. And then plus, we have a u, but our u is sine squared of x. So I'll write sine. This time around, I'll apply the square directly. Then our dv dx is minus sine of x. So because there is a minus, I will apply a minus here. So that I have sine x here. Now the most simplified answer will be cos of x sine of 2x minus sine cubed of x minus sine cubed of x. So that is sine cubed of x. And that would be one of the alternatives for your result. If someone left it in this form, automatically it means you will be having a common factor. There will be a common factor of sine x, which would be easily factorized out. And still you move on. But for this case, we can leave this dy dx at this level. And we shall have differentiated that function using the product rule. Let us now move on to part C of the question. Okay, so part C says y equals to cos squared x then sine x. We're going to again let u to be any of them. Can call this u again and call that v. If u is cos squared x, I can write cos squared x as cos of x but squared. We're again going to differentiate using the shortcut of chain rule. And that is basically going to be the u dx giving us. So I'm going to drop the power. So I will have it to differentiate the function within the bracket. And I differentiate cos x, I will get minus sine x. Then write back the same bracket, but with its power reduced by 1. I mean, you write the bracket with its content. So I'll say cos of x, of course this will be power 1, so even if I don't indicate, it means the answer comes to minus 2 sine x cos of x. So that becomes our du dx. Next is our v. Our v is given as sine x, so I will get the v dx. The v dx becomes cos of x. Now if the v dx is cos of x, we now go direct and apply the formula for product rule. And therefore it means dy dx is equals to v du dx plus u dv dx. We can now do the substitution so that we have dy dx is equals to v, which is sine x. So I'll have this as sine x. What is the u dx? U dx we got, I beg your pardon here. I mean from here, yes. We could actually modify this. If we wanted, we would modify it to minus sine of 2x. Minus sine of 2x, because 2 sine x cos x is the same as sine of 2x from double angles. So it means I will now have du dx as minus. So because there is a minus, I will put a minus here. Yes, I have a minus there. Then I say sine 2x plus. I have a plus there, u. But our u is cos squared of x. And after having u as cos squared x, now we're looking for dv dx, which is already cos x. dv dx is cos x. So it means at the end of the day, our answer will be minus sine x sine 2x plus cos squared x then cos of x. Or someone will begin with a positive term, then later brings in this. So it means you would also write it as cos squared x cos x minus sine x sine 2x. That would be perfectly the same. So you can see how the flow is. You can see how easy the questions are, as long as you already have the previous concepts of differentiation. We can now move on to part D, where we now have an algebraic function and a trigonometrical function multiplied together. So I'll log in, say let y equal to x squared, then sine squared of x. This becomes u and this becomes v. So when I let u to be x squared, automatically it means du dx is 2x. Then when I let v to be sine of x but all squared, I am going to have dv dx as 2 because I'm dropping the power. Differentiate the function inside the bracket, I'll get cos of x. Write back the same bracket with its content but reduce the power by 1. So I'll have sine x there. So giving us again, this again proceeds to sine of 2x from double angles. Then we can now look at the formula for getting the derivative, that is dy dx equals to v du dx plus u dv dx. So by substitution, we know v is our sine squared of x. The u dx, we have put 2x, so I can write the 2x somewhere here. So we have the 2x somewhere there plus u. Our u is x squared. Then the v dx, we got it as sine 2x. Now, as a matter of simplification in this case, we can conclude by saying dy dx is equal to, I can see this common factor here. There is x being a common factor. So I can factorize out x, so that I remain with 2 sine squared x, but plus, here we remain with x, then sine of 2x. So that will be our result for that case. So you realize that actually it's not a big deal differentiating distinct functions using product rule. Now you're going to try out for me part E. Only that you take care about cos of 2x, because we say in chain rule that you first differentiate the angle. So when I'm differentiating this, I will first differentiate the angle, I will get 2. Then I differentiate cos. When I differentiate cos, I get minus sine. So the answer will be minus 2 sine 2x. That is when you differentiate cos to x. Then after that, you'll also try for me the following questions. So you'll try this simple exercise here. Make sure you perfect, and also look out for very many other questions about differentiating trigonometrical functions using product rule. See you again in the next lesson, in our next video.